Okay, this is problem 3.45. A precision grinding machine is supported on an isolator that has a stiffness of 1 meganewton per meter and a viscous damping constant of 1 kilonewton second per meter. The floor on which the machine is mounted is subjected to a harmonic disturbance due to the operation of an unbalanced engine in the vicinity of the grinding machine. Find Okay, the question wants us to find the maximum acceptable displacement amplitude of the floor, okay, which is the base, if the resulting amplitude of vibration of the grinding wheel is to be restricted to 10 times 10 to the power negative 6 meter. Assume that the grinding machine and the wheel are a rigid body of weight 5,000 Newton. Alright, so from here you can easily find the formula. Okay, this question here is harmonic excitation due to base motion. Alright, this is the machine and this is the base. So you can find the formula for harmonic excitation due to base motion from your formula sheet that is available in Moodle. Okay, so this is the formula that you can use, harmonic excitation due to base motion. So you can either use this or you can either use this. Okay, so I would say it is easier for you to use this formula here because you don't have to find omega n, right? The question already gave you the K, the damping constant, and also you can find your omega. All right, they also give you the omega. Everything is given, so just straight away use this formula. If you want to use this formula also can, but you have to find the omega n first. Only then you and also your zeta. Only then you can use this formula. All right. So use this formula for the problem 3.45. It's basically very simple. So before that, I'm gonna explain to you what is x and what is y. As you can see from the formula just now, there's x and also y. So y is normally the base, x is normally what is on the base. So the base over here is the floor. Okay, also the question already give you in the figure, the machine is x and the base is y. But normally the base is gonna be the y. Alright? So displacement, amplitude for grinding machine will be labeled as x. Alright, and also the displacement amplitude amplitude for floor is gonna be the y. Alright, and if we take out all the values first, okay, so that will be easier for you guys. So the K given is 1 meganewton, right? 1 meganewton. 1 meganewton per meter. Okay, that's the stiffness. And the damping constant is 1 kilo Newton second per meter. And the amplitude of the grinding machine is given, right? Amplitude of the grinding machine or the grinding wheel times 10 to the power of negative 6. So x is already given. Meter. And the weight is also given, right? The weight is given by 5,000 Newton. Alright. Is from the formula, we don't have weight, we have m, the mass. So we have to find the mass. So since weight is equals to mass times g, alright, W is equals to mg. So you can find the m here, where the m is equals to W over g. So m, the mass, will be the weight, which is 5,000 Newton, divided by 9.81, the gravity. So your mass, you'll get it to be 509.68 kilogram. Okay then, we want to find using the formula here, so just copy it back. All right, just copy it. So just copy the formula here, use this formula here. Remember, whatever formula that you find that uses, or that the subject of the formula for the one that you want to find is amplitude, whether it is x or whether it is y, remember it is always modulus. All right, because they are amplitudes cannot be negative. All right, so substitute all the formulas since we already have all of them. All right, so you substitute all the formulas. Your x is this 1 times 10 to the power negative 6. The y, that is what we want to find the maximum acceptable displacement of the floor. All right, so basically we are going to find the y. Displacement amplitude for the floor is y, and displacement amplitude for the grinding machine is x. So we want to find the y now, so just put it as y. So substitute all the values here. The k is 1 times 10 to the power 6 square, plus the c 1 times 10 to the power 3 multiply with the omega. So where can you find your omega? Your omega is actually given in the figure itself. Okay, if you see over here, this is your omega, right? This is your omega, and your omega is given as 200 pi. That's all. All right, so your omega here is equals to 200 pi. So just substitute the values here. 200 pi square all this over k m times omega squared, square the whole thing, plus c times 2 times omega. Okay, and then square root the whole thing on the right side here. So you'll get your answer on the right side to be 5.8987 times 10 to the power of negative 2. Sorry, negative 3. Alright, next, since we are going to find y, bring 1 times 10 to the power of negative 6 here to the right side. If you bring the upper part of the fraction to the other side, it will become divide. So y equals to 1 times 10 to the power of negative 6 over 5.8987 times 10 to the power of negative 3. And then solve this, you'll get your y to be 169.53 times 10 to the power of negative 6 meters. So this is the displacement amplitude of the floor or of the base. As easy as that. You just have to use only one formula to solve for problem 3.45. That is all for 3.45.